Good morning. I had some audio problems, so I don't know if I missed you all, but it's good to see you.
Hello. Hello, Drew.
Hey, good morning. How are you doing, Roy?
Good morning. It's good for me. How about you?
Pretty good. I
Okay.
don't. I ate too much turkey over the holiday. Did,
Uh,
did you did you have a break also?
oh yeah, definitely. That's a great autumn.
Awesome.
Yeah, so the Drew, I have uh, a suggestion for you. I've tried to upload my file posted uh, two, 1 month ago. The data. I cannot access the folder of the OCP FM. So how about this one? I can send you right now, and then through yourself, you can set you help to me upload the file. Is
Absolutely.
it
And
okay?
yeah, let me make sure I can get in. But absolutely. And
Okay.
and if I can fix access, I'll do it. I don't know if I can, but yeah, absolutely. I'll do whatever I
Okay.
can.
So could you say the email, the Microsoft email?
Sure. Give me one moment to get to the share folder so I can put it in.
Mm-hmm.
So, okay, good. I can get in. I'm going to also just look and see if I can figure out why you can't get in too.
Oh, actually, this one is because of our security policy.
Oh, okay.
Yeah, so I can send you the file to you, and then please upload those files instead of me.
Sure, sure, absolutely. So, let's see. I don't see a recent file from you. Have you sent it yet?
I don't know that your Microsoft email.
Oh, I'm so sorry. I'm sorry, Roy. It's I misunderstood you. It's just Drew Walton at Microsoft.com.
Drew Walton.
Yeah, just like my name in the window, but no space and lowercase.
Okay.
I'll put it in the chat. I'm just a little slower with Zoom. Let's see. Whoops. There you go. Yeah, if you send it to me, I'm happy um, to copy the file in for you.
Okay. I will send you right now.
Okay. Great.
Hey
Um,
folks, good morning.
hey, Yogesh. We're just getting Roy's files into the folders since he can't get into them.
Oh, is there a problem with the access or what's happening?
I think he said it was a security policy on SK
Oh,
Hynix.
yeah. Okay, it's got so okay. Good.
So
Yeah,
yeah, oh,
I just sent the email.
okay. I'm watching my inbox. Oh, just got it. Okay.
Hi, Yogesh.
Hey Roy, sorry, I was looking for my mute button. How are you doing?
Oh, it's good for me.
Yeah, we were
To
just
your
saying,
holiday.
yeah, it was nice to have a break.
Yeah, for sure.
Definitely.
Hi, Ivan, and everybody.
Hi, good morning.
Good morning. It's good.
Okay, and I guess I'll put it in FMFM presentations.
Thank you.
Oh, I don't know if it says you don't have permission to move files in OCP FMFM. Okay, well, I put it in the main folder, and I was going to move it, but and did you want me to share it, or do you want to share it? How did you? What was the next step, Roy?
Were these the ones you had shared already, Roy? I thought someone had just asked
Oh, I'm
for.
sorry, I was muted. Yeah. So my plan is that this one is already shared material. Probably in the next meeting that I can share additional material regarding the DDR5 analysis result.
Okay, sounds good. Thank you.
Mhm.
So thanks, and you guess we were just getting started. So I guess
I accidentally ended up in a wrong room where I was hanging out by myself, so so I'm late.
we needed you. So well, glad you're here. Hope you're doing okay. Um, so I'll share. I guess unless someone else has a different presentation to share, I'll share the doc.
I've got Drew. I know last time we talked about talking through some of the formatting stuff. I invited Owen here today from our team in Micron. He's the one that's been working on some of the data formatting stuff. If you want to go through some of that today,
That'd be awesome.
I think at least to get a first round of feedback and kind of know where we're headed. Because we kind of put something together, but even just us thinking about it, it's going to need some work.
So how do we want to do that? Is that in this document, or is it something different we want to share?
It's not yet. So Owen has some kind of
Oh,
example code mocked up. That was another question as to how we wanted to share that and get some feedback. It doesn't, the way in its current format, it doesn't work very well to just paste it into the Google Doc.
mm-hmm. Oh yeah, I agree. Oh well, then I stopped sharing. What? Oh, and welcome. Glad you're here today.
Thank you.
Yeah, awesome. So how do we want to do this? Like I'll let you drive, and you can share whatever you want, and then and if it's okay with you all, why don't we'll take a look at this, and then we can scratch our heads and figure out the best way to share it.
Yeah. Can you see my screen right now?
Yes.
Cool. So I've just got this in a little repo right now, and I kind of went along with the JSON standard that was already in the doc, but I pulled it into JSON schema, which is if you're not familiar, essentially just a method of checking against like a hard-coded schema to make sure that any log is following the directions basically. Um, that said, nothing here is like required or permanent. I didn't completely follow the doc in terms of naming conventions, but everything that's in the tables in the OCP doc should be in here. Obviously, interrupt me with any questions. I'll just go ahead with everything right now.
Okay.
Basically,
Well, and I'm sorry, if I could just clarify one thing. It looks like this would be what we feed the memory analyzer from the decoded CPR log. Is that the intent?
yeah, essentially that's what it is. So I
Okay.
went through and I saw the three different sections, right? The boot, the crash, and the runtime. And I separated that into three different schemas, and then for each of those, I put together an example of what the data might look like.
Got it. Okay. Okay. Thank you.
So in
And that is
general,
part of what Carlos had kind of mocked up previously too, Drew, in that original JSON. I think his was, yeah, memory analyzer input schema. So this is kind of some examples and a little more elaborate version of that.
Sounds good. Well, and I'll be the first to tell you, Carlos and I had some conversations where we're both not that up to speed on how to write this kind of code and write this kind of schema. So awesome. This is awesome. Thank you.
yeah, no problem. So Evan and I had spoken a little bit, and we know that there was a little bit of discrepancy on like timestamp stuff. For all timestamps, I'm trying to follow the RFC 3339 like UTC timestamp standard. That's like the internet standard since like 2002, I think. That would be like year, month, day, hour, minute, second, and then optional time zone at the end. For other stuff like system loading, there's structures for building out like the processor loading, total number of sockets, so total number of filled sockets. Specifically with JSON schema, there are fields like additional properties and required properties that let you know like these are the things that we think as a group should be required at all times, but we should also allow like additional fields to be added here. It won't fail the validation step if that field is added or not added.
And
A lot of
sorry, I have a question about that. And so in some cases, one CPU vendor may have some proprietary tool that gathers additional data about failures. It would that how does that work? Like by saying that we have additional properties, that means they could add some additional data and it's vendor specific, or do we have a vendor specific part of the log where we can add that additional information?
Yeah, so this is like a very free-flowing thing, right? The only time you can't add anything you want is when we set additional properties to false, which I haven't done anywhere. So if a vendor does have specific information that they want to put in one of these logs, and I'll pull up the boot example, they could just put it in here, right? Like some of this stuff is what I defined in the schema itself. But let's say like if we scroll down, Microsoft wants to add something and it's just tool version.
Mm-hmm.
Like you could just throw that in here and call it like 24 or something.
Okay. Yeah, and that makes sense. So I was thinking, runtime memory I, right? If I could measure, the I over the last hour, that throw that in, that would be kind of cool. Or a time domain reflectometer that finds a bad, and that's just really pie in the sky at the small size of memory subsystem. But that kind of thing. So
I was
that's
just
perfect.
gonna say, yeah, Drew, let's do that.
Why not? Hey, I'm gonna turn it around. It's just silicon. That's the software thing. It's just software. So I'll just turn around and say it's just silicon. But yeah, that's perfect. Thanks, Owen, and thanks for bearing with my humor.
Yeah, no problem. Yeah, and I think I'll reiterate one more time that the benefit of having a predefined schema is that when we would check, the data coming into this tool, if it didn't meet that schema, it would tell you exactly what you're missing or what you're not missing, or like if something is wrong with your syntax or anything like that. And I'll show a better example. So for me, I know I work in Micron on a lot of like data that is shared with us, and one of the biggest issues often is that we don't get like information on the DIMMs like serial number. So If I scroll down to the installed memory, what it does is it creates an array for the installed memory, and that's just defined by the schema. And then in that array, if you're familiar with like Python terminology, there's dictionaries. It's very similar to how JSON works. And all of that information is stored here, right? So this array can be any size. I mean, it doesn't matter, what your loading is in your motherboard. It's just what you're putting in the installed memory property. And then for stuff like registers, like PMIC registers or RCD registers, what we can do to sort of future-proof that is use a pattern property, which is just regex, right? So for example, if you want to call it like register, all you would do is look for the word register and then some number after it, and you can add as many as you want and all their values. I know this might not be how it's gonna stay, but that's sort of the direction I was going with, maybe using regex for some of these properties. Does that make sense?
Yeah, I guess I'd defer to the people that are going to process the data. So let's propose it and see what folks say.
Cool. Yeah, and then I had mentioned earlier too, there was the required fields, and I think this is probably something that everyone's going to have to agree on. But for now, I just put some examples in here to sort of a generic standard on what I thought would make sense to be in here. Like I said, the additional properties is always set true, so that you're not limited to what you can put in here.
Okay. That makes sense. This is really interesting. Well, so Roy, I think it'd be very interesting to hear what you think of this. And do we have anyone from? I'm looking to see if we have anyone from Samsung. Yeah, we do. Okay, Yoon. Maybe what we'll do is, I mean, we'd love your feedback right now and see if you are interested in this. And I would maybe we put this in the folders and I'll send links to you and we can review it. Or how do we want to do this? And please keep going with whatever you have on. But I'm excited. This is something we sorely needed.
Oh, yeah. I agree with your opinion. So after this presentation, when we got this code, I will analyze in details in our site, and then feedback here. Thank you very much. It's a very good initialization of the schema, what we are eventually going forward.
Yeah, no
Yeah,
problem.
thank you. So could you briefly explain about the runtime schema again, as runtime schema in more detail?
Yeah, sure. So right now, essentially, so that it's easiest for the logs to be processed, what I did is set this up as an array of what I'm calling memory event logs. And I'll say this again, if you're familiar with like Pythonic syntax, it's basically just a list of dictionaries. And each dictionary is just a single log event, right? Like let's say a failed read. And inside that, you have like your date time of the error, the DIM information like part number, serial number, and then some system information like channel or channel slot if it's multiple DIMMs per channel system, temperature, and then I wrote some other stuff in here. I know some of this is probably not gonna stay, but like error source between machine check, an Intel read retry, maybe patrol scrub or ECS or something. And then correctable state, whether the error was correctable or not, the physical address, and this is as seen by the operating system. And then further down, this breaks into the actual like DRAM location stuff. So rank, subchannels, an identifier for which device is in error, on that subchannel, and then further into the die, the bank group bank row column. And then this is one, Evan and I were briefly talking about this together yesterday. I put together what I call just a burst map. So like whatever read you're on, all of the bits of that read and how they map to the individual bits and the DQs that they're on. This, I think, there's kind of two directions we could go with this. I think the easiest one. Go ahead.
Oh, yeah. One question about the burst map. Probably this one means where the flipped error will happen in the EQ and BLY. Is that true that?
Yeah.
In that sense that how can I describe the multiple bit flips, simultaneous multiple bit flips per read with this format?
Yep. So essentially, right, what we're looking at is inside of our, what did I call it? The memory event log. It's one Python dictionary. And inside this Python dictionary, there's this burst map key. And this burst map key is itself another array. And for each like tuple in that array, you have the DQ and the burst bit, right? So that lines up.
Understood. Okay. Thank you.
Oh, that's interesting. Okay.
And actually, what I want to say too is that there's sort of two options for this, right? Is that if we keep this burst map, you're looking at flat data with a repeated record in it, and to get all of the actual individual like bits and DQs out of that into a flat table, you would just need to explode on the burst map column, because that would get you each of the bits and DQs out into the original starting address at row and column. But that's not a complicated operation. So this is very much something that could be changed to fit whatever format.
I do have one quick comment. I noticed you said read, retry, or patrol for the source of the error. Read, retry is an Intel term, so it may just need to be demand or patrol.
Right.
Yeah.
So if you change read, retry to demand scrub is the generic term, and the read, retry information is the Intel way of getting it.
Did you say demand or command?
Demand scrub. So demand scrub is when you read an error, you see an ECC error, and you scrub the error right then.
Gotcha. Yep. Okay. And then the rest of this stuff is like PMIC runtime registers, and that again follows the regex field look, and then some processor metadata, and I have some to-dos in here for myself just to add register names for what might be interesting. ECS stuff, system event log I added in here. I don't think system event log was in the OCP doc, but I know we found value in that in the past.
Well, what we're doing is the way to think of the system event log is it's kind of a precursor to getting CPERS out of band. It's the old thing. It's a part of the IPMI standard, and the problem with it was that you could only put a tiny amount of data in any given event, and so with the CPERS, I mean, if we want to embed cell entries in CPERS, I don't really care, but the CPER can just have the error data, fully described. So we don't have to try to summarize it to a very small terse event. So the mental model for me is CPER replaces SCL.
Gotcha.
Getting data out of the system. So anything we put in the SCL, we could put in CPER. And if you want to make an example of how to put a cell entry into a CPER, that's fine. But I would, like long term, I'd prefer just, that be a CPER entry.
Sure, yeah. I think obviously we can spend as much time looking at this as we want right now, but I think like you said before, the best option would be to get this uploaded into some folders and let everyone put some feedback in the in between lines. Does that make sense? Or does everyone want to kind of keep looking through this and maybe walk through some of the example data?
I'm open to whatever would work for folks. So, folks, please speak up. If it may help to have you kind of give us a guided tour, and then we come back, look at it and come back with questions, or people may be ready to just dig into it. So, what do you all think? Would you like Owen to continue walking through this, or do you want to just upload it and review it?
I think this is good because people can ask questions and make corrections right away.
Okay.
Sure, yeah. So I'll just start from the top here and walk through like the boot log examples, and then just stop me if there's any questions or corrections we want to make. Essentially, this is just made up data. So there's going to be some weird stuff in here that doesn't make any sense. But what I put in here is what might look like, coming from the boot log of one of these systems that's monitored. So there's system loading, and the system loading property has the processor loading property, which itself has, information about socket counts and types and how many processors are actually loaded in those sockets. There's DIMM loading, and then some firmware information. And then, like I'd shown before, there's that installed processor and installed memory properties that give you the actual details of each processor and DIMM that are loaded in the system. I'm not sure, if we're interested in like PCIe information, but I didn't add that in here.
And I guess, if you look at some of that stuff, do you mind scrolling back up to the processor information? Just
Sure.
trying to see if it's pretty generic. I think that's probably pretty generic. Yeah, we'll have to get AMD to take a look at it. But okay, that makes sense. In the ECC mode, maybe, like, I guess there may be enabled or disabled, but it may be, ADDC mode or 128-bit mode, or,
Yeah.
there may be, other names of modes. I guess we don't.
Yeah. I didn't, for this one, I didn't make it so that you have to like say enabled or disabled or true or false, right? So if we look at the actual boot log schema and we go to the processor data, it's just a string. So I have a to-do here to expand it into, what might be viable to put in there, but I didn't enumerate it into anything that will fail if you put the wrong thing there.
Yeah. Okay. And I guess the thing to think about is that I think that we may have different ECC, like, different CPUs may have different ECC in the same family, right? Like an older SoC might have a different. I'm not talking about. If I buy an Emerald Rapids, I would expect Emerald Rapids to generally have the same list of modes. But now, if I buy, the super new Rapids, just making a name up. Don't take this as me saying something confidential. But if I had super new Rapids, it might have a new set of ECC modes that reflect some improvement. So we'll have to think about that. It may not. I don't know if we can enumerate it, or we may need to have a thing that says yes, ECC was enabled, and by the way, here's the name of the ECC that was active, and the name may be vendor specific. In fact, the name will be vendor specific. Because every CPU group does their own ECC their own way.
So we want to make it like I don't know what's the right answer, but just thinking out loud, we just need a number of bits. Is that all we want to capture, or you want to keep it generic as a name, and then whatever is behind the name, the vendor knows?
I guess I'd kind of think that the name would be good, but I don't know. I mean, that way you can do whatever you want with the ECC, and you just have to have a name for it. What do you
So,
guess? I'm mute. I'm very interested in what you think.
I think what you're thinking is also valid. And like I said, I have no like I'm just thinking out loud here. Yeah, that will work, I guess. Right.
so Drew, what are you thinking about in terms of how we name the CPU or how we, track that? So, an Emerald Rapids versus an AMD, how,
Well, so the yeah, different CPUs have different memory controllers, and
right.
it's a little bit different, and so there may
Yes.
be something unique
Yeah,
about that processor that we can key off of.
right. So my question is more around how are we going to give each processor some universal through ID, or do we just, how do we identify the different CPUs, and whatever naming technique we use there is the same naming technique that we can use for the ECC. So again, back to the example of if we decide to call the CPU Emerald Rapids, then what are the different Emerald Rapids ECC options? And that's what we call out. And
Yeah,
AMD will have their processor name and their ECC mode names.
exactly. So my thought there was there are two kind of basic approaches. One is you create some registry of names and people go grab the name they want. But the other thing that might be simpler is, if you look at processor vendor name is Intel. So, then all the other stuff below that, if AMD wants to have a Sapphire Rapids, you could be kind of silly. It would be poor product management, but they could do it, and we would be able to tell the difference because it was an AMD and not an Intel. So I
Right.
don't know. And I'm not saying AMD would do that, just so if anyone gets back, don't get me in trouble with Carlos. But I'm just saying they could, and it would still work.
Right. But my point is kind of whatever naming naming or tracking or what have you that we use for the processor can also work. That naming convention can also work for the ECC modes.
Yeah. Yeah. Well, and I
It-
was thinking that exactly that is that if it's an Intel, processor, then, Intel names its ECC modes, and it's, kind of their problem to know what their ECC modes mean, what their names mean.
yeah.
And in terms of yeah, the ARM is going to be interesting because you might have an Ampere, you might have a Microsoft ARM or a Google ARM or a AMD ARM. Um, yeah, so that'll be interesting. We'll have to figure that out.
Is
And it,
it just dawned on me. Does JEDEC have some standard on how devices are labeled, like kind of a FRU standard or something like that?
not that I'm aware of.
Okay.
And
Uh,
that's actually something I talk about a little bit later in the document, is that, when like these error logs will refer to memory in terms of the media address, right? Which socket had it and which rank bank row column, all that. And when we need to actually replace a DIMM, someone's got to convert the rank number to a DIMM slot or something, and that's okay. That's if I buy a Cisco machine, then I would expect Cisco to have a way to do that. If I have a homegrown machine, then translating from a chipset ID to whatever we silkscreen on our systems is our problem. But we've got to, so we got to figure that out. I don't think you can do things like embed the fru names into the system via. I've seen ACPI tricks for that. I think if you run memtest x86 on a machine, it can tell you the DIM slots. But so I don't know. I mean, we need to think that through, Charlie. I'm not sure exactly how that would work, and I'm not sure I'm even addressing what you wanted me to. But
no, exactly. Yeah. So I think that stuff we can kind of work out.
yeah, it's important. It's absolutely the technician has to replace the right part.
Yeah. How many times does that not happen?
Oh, yeah. Uh, yes. Uh, I've seen someone pulling the wrong machine out be the feather that broke the camel's back.
Yeah.
It's just like the coup de grace of a ongoing problem. Yeah.
I
Okay.
didn't see it. Sorry, I had a question. I didn't
No,
see
no,
it
please,
here.
as always, Meet. I love hearing from you. Thank you. Please speak up.
Are we going to embed some kind of checksum or CRC check on this data here? Because like a lot of these fields are of variable length, and if there's any problem in the decoder, the CPER decoder, I think like having a field for a checksum for the various sections or a indication of how many bytes to expect, something like that would be a useful thing.
Yep, and you can actually do that pretty easily with JSON schema. So if we do, I think it's max length. That is how many characters you expect at max, right? So like, let's say our longest processor vendor name is 20 characters. If you put 21 characters as your vendor name, then this would fail the validation step.
But I guess also, isn't there a CRC or something on the CPER? I'm trying to remember. Mita, were you suggesting that we may need to be able to make sure the JSON didn't get corrupted?
Yeah, that's roughly where I was heading. Like if we had a CRC on the, I don't know, on like either on different sections or on the whole thing, that would be an easy check to know that we're not getting corrupted.
Well, and this would be decoded locally. So, and I guess, what do you call it? Idempotent, where you can go from one thing back to the other. This isn't really idempotent because the someone might log a raw syndrome and then calculate the bit flips when they decode the error log. So it wouldn't necessarily be idempotent. Yeah, I guess that since it's local and it's used locally, it may be less risky for corruption, but we should think about that. I don't know. Sorry, Mita, you're hearing me kind of process what you're saying out loud. Sorry, you're hearing some random thoughts, but yeah.
No worries. Yeah, I just wanted to bring it up and see what folks thought about it. Like as part of the decode process, just adding in a field, that either indicates checksum or number of,
Or length or something, yeah.
yeah, length or something like that, yeah.
So, Owen, what's a good practice there? With a JSON file, I have no idea.
I think that kind of depends. I mean, I've seen like internally maybe like a threshold for number of records. But typically if your JSON file gets corrupted and you're missing like portions of your syntax, right, or characters go missing or random stuff gets added in there, because the schema is always consistent, or in any case you can always re-pull the schema down from somewhere like GitHub. The odds of that being corrupted are pretty low. So when you run the actual validation step, when you cross-reference the schema and your data, the schema will detect that there's something wrong with the data, like naturally, and would flag that.
Got it. Okay.
Okay.
Okay, that makes sense. Okay. Well, please continue.
Yeah, of course. So I think we were working through this example. I'll keep scrolling through. If there's anything else, obviously. Pulled in the installed memory. This is just more DIM information like vendor, some kind of ID maybe if that exists in the system, a little bit of information on the hardware, where it's installed on the motherboard, and then some pretty simple examples, but
So the speed here is the rated speed of the DIM, right? It's not what it's operating at.
I mean, I guess that depends on what you're interested in, right? We could have two, which is like a rated speed and an operation speed, right?
Presumably how it would the part number infer that, or the serial number? I guess that'd be a huge lookup table with a serial number, but how does that work?
It is in the part number, Drew, for the rated speed. So
Yeah.
I guess to me, Yogesh, in here, operation speed is most important, I would think.
Yeah, I agree with that.
The work week somehow did something that can be deduced from the part number and serial number?
For us, yes.
Does it make sense to just have a field for it, maybe, if it's, if it's too obscure?
Evan, you might be able to answer that better.
A field for
Work week,
the manufacturer work week of the DIM,
yeah.
or for, that's what you mean, Mita?
Yes, yes. Because oftentimes, there are problems that can, get bucketized by work week.
Yeah. Yeah. I don't remember exactly how easy that is to pull out. To Drew's point about a big lookup table, I'd have to at least take a look and see if we could do that easily. I don't think we can.
Yeah, I think
Typically,
from,
go ahead, Don.
oh yeah, I think from my perspective at least, that information is not easy to pull out. I don't think it's contained within it's definitely not contained within the part number.
Yeah.
So with my question was, is that information something you typically use by itself, or when you get into what part number, what serial number, there are like a huge lookup table of lots of characteristics of that DIM, and that's kind of getting deeper into the debug. Is that how general use case is for that kind of information?
Yeah, I mean, the work week by itself doesn't really tell us anything, Yogesh. So I think, yeah, for deeper, I mean, to Mita's point, that she's right that there are often things that can be kind of bucketized by, oh, there was a manufacturing issue in these 2 work weeks or something, but that takes a lot of other data to kind of land on that.
Yeah, that's not like innate information to the work week, right? Like
Yeah.
just knowing the work week doesn't mean that there is an issue in manufacturing at that time. So that's sort of like a 2 or 3 step process. Definitely not something that would be built into a deployable tool like this.
Normally the work week information of each DIM is not explicitly represented in the DIM serial number or something. So it depends on the vendor, and even for the one vendor, for example, the SK Hynix, some portion of the DIM includes the work week information. But I think it's very difficult to generalize how we can get those information from the DIM. So how about this one? Regarding the work week information, if we can add those information in the schema, then the additional property for each vendor, vendor-specific properties we can add.
I think, I mean, yeah, that makes sense, right? I don't have that as a requirement, right? Like in my requirements for these
yes.
installed
Mhm.
memory, that's there. But if you wanted to add that, you're not limited, you know?
Mhm. So as you all might know, work week information is very important one because normally when you see there's some process event of the DRAM device process, then the work week information is the first first info we have to trace. So in SK Hynix, we will provide to the end customer who was using this schema those information, but it's that information would be the vendor specific.
Yeah, and on the subject of work week, would it be the work week of the DRAM or would it be the work week of the DIM assembly? And
Yeah. And
yeah,
normally
so
the DIM assembly is we can get easier, but each DIM for each DRAM is quite difficult to tracing. So I think the DIM is the right one for this one.
and there might also be different manufacturing sites, right? So SK Hynix might have multiple DIM assembly sites. So just work week by itself isn't necessarily an indicator. I think my experience has been when you get into the serial number lookups, that then becomes a very customer DRAM vendor specific study. You've got that the customer has a list of serial numbers that are bad, you know, a large list. Otherwise, if it was just one DIM failing, we wouldn't be bothering trying to trace the history of that DIM, but a large group of DIMs failing. And our question is, okay, so what do these DIMs have in common? We give the serial number list to our memory vendor, and then they have their own database of serial numbers and where things were made, what was made, things like that.
Well, and you know, we want to do this analysis in our data centers on the fly as we have memory errors. And so, you know, if we can do it based on serial number, that's great. The work week of the DIM or DRAM seems like a shortcut to make that easier because you can say, I know I had a problem on these work weeks. And so when you see this error, you just go ahead and replace the DIM. It's going to get worse, right? I know I had a manufacturing problem or something. So I don't know how we do that,
Yeah.
but we definitely want to be able to do that in an automated way at scale.
Yeah, I agree, Drew. The downside though is if the customer or the server center says, "Oh, this particular work week, these DIMs have a problem. I'm going to yank all the DIMs from that work week." Now all of a sudden you've got a tsunami of DIMs going back to your DIM supplier, and maybe not all the DIMs in that work week were going to fail. It was just a subset. But with the limited information you have, you might have a trigger finger.
Well, but it depends on the error too. You know, it may be a particular error pattern in a particular work week range. So all I'm saying is that, you know, we just want to be able to factor that into the analysis at scale. And I'm not presuming too much. I was just giving a random example of how it might work. But you know, we definitely need to be able to factor manufacturing problems or serial number range problems or work week range problems into the analysis. And I don't know how to do it, but you know, I think we got to figure something.
Sure. It's a topic for future discussion. I agree.
I'm sorry to interrupt. I lost my internet connection for a second there. Did
Oh.
I miss anything that anyone wanted me to add here? Or
I mean, we're talking about we need to puzzle through it. So that what you've put is a great conversation starter. And So that's great, Owen. And you know, if people have feedback, I'm not saying this is the total answer, but it's a good start, and we can give you feedback. That's great.
Cool.
And
Thank you.
and try to figure it out. But I think the gist of it is we need to automate this at scale. And if there are, you know, manufacturing components, that analysis seems like Workweek or, you know, maybe it can be done by serial number. But if you as the memory vendor, if you're giving me code that I'm going to use to analyze errors from millions of DIMMs, you know, like, what do you want to pass yourself? So if Workweek helps you, then by all means, let's put it.
Gotcha.
Oh, okay,
All
thank
right.
you so much.
The rest of the stuff is pretty quick. This is all of those pattern properties for registers, and I put some examples of them here. So you just see register 1 as an example, but you could add like register 45 if you wanted to. Or if you wanted to do you see, this is actually already checking against the schema. So it notices that there's 2 duplicate objects here, but if we rename this to 2, it'll pass. Any questions on this, or do you want me to try and quickly walk through some of the runtime information?
Nothing at this moment in SK Hynix. We will go over the runtime schema again and get back to you later.
Cool. All right. This
Could you-
meeting,
yeah.
yeah, I was gonna
Sorry,
say this meeting ends in a few minutes.
Is PMIC boot register, is that all the information to be captured about PMIC? Rest is inferred from the serial number?
You mean like the PMIC version?
Yeah. I'm not sure it's going to be firmware version also on that. I'm kind of guessing here a little bit.
Yeah, I'm not totally sure. Evan, I know there's some stuff about like MPN. Is that stuff we can discuss, or?
I mean, yeah, that depends. I don't know what visibility we'll have to the actual PMIC serial number, Yogesh. Do you guys know if we get that runtime, boot time? I think the short answer to your question is there's probably more registers than that.
Yeah,
Like
this is
Owen-
just an
Owen just
example.
kind of has an example in there.
I see. Okay.
We
Yeah.
we have the full list in the FMFM doc. We just
Right,
need
that's
to
what I was
capture
thinking.
those in
That's
there.
the right
Yeah.
place to capture the details. This is just a kind of example. Okay, thank
Yeah.
you.
And the SPD on the DIM itself has a ton of vendor information in it, right? So
Yeah, that's a good point too. Is there something specific there, Charlie, that we'd want to be sure to call out?
yeah, I'm not sure.
Okay.
We would it's Jetica standardized it so we can kind of go through the list of what information is in the SPD, and do we capture all of that information and archive it when the system boots? I'm not sure. So, but that's something we could kind of walk through the JEDEC spec for what's in the DIM SPD and say, this is important stuff. Let's capture it.
Yeah, I think we probably do need to figure that out. And like these error logs could be, you know, really big if we send all of the boot. You know, so we got to figure out how to send the data and when, as well. And when do we send the SPD data? You know, do we send? We don't want to send it with every corrected error. It's a boot time thing. So, yeah, I think what you're saying makes sense.
It's a good point. And how about the PMIC manufacturer and the LCD manufacturer information, the DIMM information? Is it already included here?
I don't have that included here, but that could be a field that I
Yeah.
add past
Okay.
here.
Okay.
Yeah, and that actually might be a case of that's been standardized in JEDEC in the SPD. So each PMIC manufacturer has some JEDEC assigned ID, and that then gets put into that particular DIMM's SPD.
Okay.
Gotcha. All right. So that's pretty much it for the boot log example. I know we have 4 minutes here. Do we think it would just be most beneficial to let everyone review this on their own time? We'll get this uploaded to the folders, or?
Sounds good. Yeah, I think so.
Cool. Well, I will get the most up-to-date version over. What's the best way to do this? Evan, do you want me to just share it with you, or?
Yeah, I'm pretty sure I have. You're just talking about the Google Drive, Drew.
Yeah,
Should
yeah,
I just
and
make
then
a subfolder in there and
send, yeah. Do you mind doing that?
Nope.
Make a subfolder, and then just can you send an email out on the Groups IO email link? You know, where we get our meeting announcements.
Yep.
And then just say, hey, they're here, and put a link in. That'd be awesome. And then
Yep,
if you
I
need
can
help,
get that done.
and then yeah, if you need help, ping. Yogesh and I can help. But you
Yeah,
should.
I've never done something without running across some kind of security issue on Micron side or something. So
Okay. Well,
I'll
I'll help
let you
if
know how it goes.
sounds good. Yeah, yeah. Okay, thanks a bunch. This is great. Oh, and it's really great to have your help here. We really appreciate it.
Yeah,
Yeah, thank you. Glad to be here.
Awesome. Okay. Well, thanks everyone. Why don't we give you a few minutes before your next meeting?
Yeah. Thanks, Drew. Thanks, everybody.
Thank you.
Thank
You're
you,
good.
everybody. Thank you again.
Thanks.
Bye.